Hello everyone, and welcome to section 8.6, where we are solving rational equations and inequalities. I am splitting the screencast for this into two sections, just like the homework, because there are some very ACT-like word problems in the other half of this section that we're just going to kind of deal with on a separate basis. So we have several different types of ways that we can solve these guys. If we just have one ratio equal to another, then we can simply cross multiply and then solve for x. So here I have one ratio equal to another, so I'm going to cross multiply, making sure I distribute to both pieces. Or all three pieces if I had more than two. At this point, I am solving for x, so I can subtract 15, add my 40, I get 5x equals 15, so x equals 3. Now the nice thing with these, technically we're supposed to check all of our answers. However, if we go ahead and make that excluded value list right at the beginning, so here I have an excluded value of 5/3, and here I have an excluded value of 2, all I need to do is cross-reference my answer to my excluded values. If it's not on that list, presuming my algebras are right, I'm good to go. Now if I have addition or subtraction on one side of my equation, I do have two choices. I can either add and subtract, so find a common denominator, combine like terms, and then cross multiply, or just multiply the whole equation by the least common denominator, which is usually easier. So if I'm looking at both sides of my equation, I want to make sure I get the least common denominator for the whole equation. So here my least common denominator is 3x. Here my least common denominator would just be x, so overall my LCD is 3x. Here I'd be missing a 3, so I'm going to multiply my numerator by 3. The idea behind multiplying the whole thing by the LCD is you're going to get rid of your denominator, so you're just left with a nice regular algebraic equation, no more fractions. So since here I would multiply by 3/3, I've got 8 times 3, which is 24. Here I'd multiply by x over x. And finally, I have 3 times negative 14, since I already have an x in my denominator, so I have negative 42. As all of my denominators would be the same, I'm essentially getting rid of the denominator in its entirety and just solving this equation. So I'll subtract 24. So I've got 11x equals negative 66. So x equals negative 6. Now I do want to make that excluded value list. So x here cannot equal 0. Since negative 6 is not the same thing as 0, I know my answer is going to work. If you wish to go ahead and check and plug into those atrocious fractions, feel free. However, once you have your excluded value list, you're okay. Now let's take a look at another one, very similar. We have a choice of either combining these guys or just multiplying the whole thing by the LCD. So I'm going to make sure that my denominators are factored. That's factored, that's factored. So if I look at either side of my equation, here my LCD would be x plus 4, x minus 4. Here it's just x minus 4, so overall it's x plus 4, x minus 4. This denominator already has both pieces, so I'm just left with the 6x squared. I've got a minus sign, so I've got to watch out for that. So I've got a 3x, and here I'd have to multiply by x minus 4 over x minus 4. So I've got to make sure that gets distributed to my 3x. And here I've got the x plus 4 that's missing. I'm going to distribute my negative, so it makes it a little bit easier to solve at that point. So I'm going to subtract 4x and subtract 16. So I've got 6x squared minus 3x squared, which just gets me 3x squared. A 12x minus a 4x, which just gets me 8x. Minus 16 equals 0. At this point I need to factor. They don't have a common factor, so I can't pull anything out. So I do just have to factor in whichever way you are most comfortable with, whether it is grouping it and turning it into 4 terms. Some people like the x method, whatever you wish. So I get two values. I get x equals 4/3 and negative 4. Again, I want to go back to that excluded value list. You can always do this at the beginning. So x cannot equal negative 4 or 4. Check my values against my excluded value list. Negative 4 shows up. So 4/3 is my only actual solution for the problem. Now I will occasionally have inequalities with these. So the way that we do this, we are sort of going to make a sign chart, kind of like we did with quadratics and inequalities. So we're going to state the excluded values first. Then we're going to solve the related equation, so we're going to change the inequality symbol to an equal sign. Then we'll solve that equation and use that value as well as any sort of excluded values to sort of make our sign chart and see where it works out. So I've got my excluded values of here I have x cannot equal 0. Then I'm going to turn it into an equation. Multiply both sides by my LCD. Here my LCD would be 5x. Here my LCD would just be 5, so overall it's going to have to be 5x. Here I'm missing a 5. Here I'm not missing anything. And on this side I'm missing a 8x. So I got a nice 5 plus 3, which is 8. 8 equals 2x, so x has to be 4. Make my sign chart with my excluded value as well as any sort of solutions that I found, and test values. So let's test negative 1, 1, and 5. If I plug in negative 1 here, I have negative 1 plus negative 3/5. Is that less than 2/5? Well, I don't care what that is, it's a negative number. That is less than 2/5, so we're good there. If I plug in 1, I get 1 plus 3/5. Is that less than 2/5? Not a chance. And our last one, let's plug in 5, so I've got 1/5 plus 3 over 25. Is that less than 2/5? 3/25 isn't even 1/5, so there's no way that that's going to be greater than 2/5, so that makes it less than, and our solution area, x is going to be less than 0, and x is greater than 4, because we want to go towards the check marks. And that's our answer. We'll look at a couple more of these in class, and I'll see you then.